Good evening, everyone. Welcome to the Tucson Amateur Astronomy Association monthly meeting. This is our first Friday of the month meeting. We're here every first Friday of the month at 6:30. And so we're glad to have everyone join us who can. We have people attending in the room with us in person tonight. We have people attending on Zoom, and we have people attending on Facebook. We will be having some speakers, and we will ask you to either hold your questions to the end of the speaker, or if the speaker so indicates, you can interrupt them. But that's up to the speaker. And we will ask you to put your questions into the chat if you're not attending in person. And we will make sure and get everyone's questions. We always think everyone's question is important. And we certainly will be glad to spend time with your question and look forward to the extra insights that we will get from that and talking about things tonight. So I need to ask as we're starting here that people who are in the room with this be very sensitive to noise, because anything you say in the room may be picked up by the Zoom, and people may actually be able to understand what you say. But even if they can't, they certainly can hear sounds from that. So we ask people in the room to be very patient and to try not to talk until we're having questions. And we also, we'll let you know at different times in the meeting kind of what's happening when or what's happening next. We are going to have several things going on tonight. I do need to announce to our TAAA members and remind them that we are in process of voting, and everyone who is a member of our organization has gotten an email, or should have gotten more than one actually, email about a possible change in the Constitution and bylaws that's being voted on. And the last time to vote on that is at 7 o'clock tonight. So if you have not voted, then you need to quickly access your online vote option here and vote if you would prefer to vote on the Constitution and bylaws change. And we would appreciate everyone who can participating in that. So we will move now to our first presenter. We have with us Dr. Mary Turner. TAAA members are very familiar with Dr. Turner. She's been a member with us probably, I don't know how many years, probably 25 years, she says. And Dr. Turner has just wonderful insights in astronomy. She is a master astronomer, and she gives quarterly presentations for us in the club about what's up in the sky for that season. So Mary, if you're ready, we'll be glad to transfer here to you.
So I guess I can hear me, so I guess you can hear me too. And I don't speak Mac, so hopefully I'll get this right. But yeah, so here is our, okay, you told me I just had to press the left and right arrow button. That's speaking to it in Mac.
How about up and down?
Okay, so as usual, we're going to start with a little bit of myths and legends about one of the constellations. And one of the constellations we can see readily over the next quarter will be Perseus. So we'll talk a little bit about some of the lore related to Perseus. And then we'll look at several other objects. And of course, they're broken down into a little bit of everything. You know, I like galaxies. I like multi-star systems, nebulas are pretty. So these are some of the objects we'll be talking about as I go on. But we'll start with our little bit of myths and legends and lore, starting talking a little bit about Perseus. And of course, Perseus, you can see the simple captures from the sky, sort of a star map, as well as sort of the representation of the character himself. A little bit about Perseus. Acrisius and Proteus were princes of Argos. And, as princes, you'd think no, we've known enough princes to know they're not going to share equally. It still works that way today. But, even though they were both pretty, higher up there, they basically tried to cheat each other out of their fair share. And eventually somebody wins, in this case, Acrisius, and he sent Proteus away. But there was an oracle, and we all know about those oracles. They never prophesy the good stuff. They only prophesy who's going to die and whatever. So why does everybody always go to the oracle to get their wisdom if you know everything they say is going to be nasty? I mean, just asking. But basically, the oracle indicated to Acrisius that the son of his daughter was going to, in some way, cause his death. So he decided that the best way to prevent this from happening was to seal his daughter in a tower, a loving father. What else can you say? To prevent her from getting married, and therefore she's not going to have a son. But of course, we know that gods, in particular Jupiter, we've all heard about Jupiter and his antics, are not really all that concerned with an impregnable tower. He can get anywhere he wants to go. Okay, so in the guise of a shower of gold. Hey, it beats what being a bear and being a lion and some of his other apparitions that he showed up in some of the other lore we've talked about. He entered into the tower, and then 9 months later, Perseus was born. Now, Acrisius, he locked his daughter away in this tower, but he couldn't kill her. And he couldn't kill her son, his grandson, his only heir. So he placed them in a chest and set it out into the ocean. And we thought dysfunctional families started with the Kardashians. What can I say? So a fisherman, and they're always, simple. All the simple fishermen are always kind-hearted. And he found the chest floating in the ocean, rescued them, and raised them as part of his family. So Perseus was allowed to grow into adulthood in the nice, simple surroundings of this fisherman. And in the role of the son of the fisherman, he acquired a great strength, skills, personality, things that you wouldn't necessarily have if you'd actually grown up the son of the king or the grandson of the king. But it turns out that this lowly fisherman was from another dysfunctional family, and his brother was actually a king as well, Polydectes. It gets better. So one day, Polydectes found he was suddenly a widower. His wife passed away, and he needed a wife. Now, since Danae, who was Perseus's mother, had royal blood, and she was reasonably attractive, he figured, what the heck, let's go for her. But she wasn't really all that into him, so she rejected his advances. So again, out of the kindness of his heart, he turned her into a slave. Now, Perseus at this time was, starting out on his quest to, explore the world, to figure out how to get himself back into what he felt was a proper role, which was as, the grandson to the king. But during this trip, he decided that what he needed to do was to kill Medusa, the one that had the nice hairdo. And of course, that's all built into all of the lore of this part of the sky. Then he did return home before he went off on his quest, found out what had happened to his mother, got really upset at the king and tried to kill him, but it was the farmer, the fisherman who had raised him, convinced him that that would not really be a good idea. So he simply removed his mother from the castle where she was being held as a slave and took her to Aphrodite's temple, figuring at least there she'll be relatively safe, because nobody messes with Aphrodite. Okay. Polydectes realized that Perseus being around was not necessarily a good thing. He might have been stopped from killing him once, but you don't want to necessarily depend on that going into the future. So Polydectes decided the best way to deal with Perseus was to find a way to get rid of him, but make sure that his fingerprints weren't necessarily all over it. So Polydectes throws a party, and out of the kindness of his heart, he invites Perseus. Okay. Now, in these days, as well, probably as some today, when you're invited to a party by the king, you're expected to provide gifts to the host, and the gifts have to be suitable for the stature of the host. Now, the host is the king, the invited guest is the son of a fisherman. He didn't exactly have an appropriate gift to provide. And of course, that subjected him to scorn from everyone else who did have gifts to provide. So basically, he got a little angry. And as we all know, most of these Greek and Roman characters tend to have a great deal of pride. His was hurt. So he boasted that he could provide the king the greatest gift of all, which was the head of Medusa. Polydectes knows a good deal when he hears one, figuring there's no way this guy is going to be able to defeat Medusa. Medusa is not known for letting those who try to kill her get away. So he can now, take care of everything all at once, because Medusa will kill Perseus. He won't have to deal with Perseus anymore. And he had nothing to do with it, because Perseus was the one who made the offer of the gift in the first place. Okay, so turns out that Perseus was a relatively good guy. Aphrodite was willing to help take care of his mother. So some of the other, gods and demigods were willing to help him as well. So Minerva, Mercury, the Gorgons, a little bit of help from Atlas, allowed him to actually kill Medusa. Atlas asked him to actually show him the head of Medusa, because the problem with looking at Medusa is you're going to get turned into stone. Okay, so when you were cutting the head off of Medusa, you couldn't look directly at Medusa or you'd turn into stone. But Atlas, was sitting there holding up the world, had the weight of the world on his shoulders. So he figured the best way to get out of this predicament he was in was to just get turned into stone. So he wanted Perseus to show him the head of Medusa just so he could turn into stone and therefore wouldn't have to worry about holding up the earth anymore. Actually, not a bad idea, I guess, when it comes down to it. And so Perseus did so. Atlas helped him kill Medusa, so he might as well repay the favor. And so now we have the Atlas Mountains in Africa, which is what happened to Atlas when he got turned to stone. And you can't prove otherwise. I saw those looks on your faces. You cannot prove otherwise. And I do not believe any of this is fictitious. But then Perseus tries to head home, flies over the kingdom of King Cepheus, where he's another fine father who has chained his daughter to a rock to be attacked by a sea monster to save his kingdom. And Perseus sees Andromeda, who was young, relatively attractive, and thought he was a better suitor for her than the sea monster. So he rescued her from the sea monster, again, using the head of Medusa to turn it into a stone. Then he married Andromeda, and with his wife Andromeda and lots of money, he makes the last trip of his trip back home to see the king. Now, obviously, his mother is happy to see him. His little quest took about 7 years. He spends some time with her and then goes back to see Polydectes. Turns out that Polydectes was having another party. I'm sure over the 7 years he had several, but there turned out to be ones that occurred simultaneously to the return of Perseus. And of course, Perseus decided to be a gatecrasher, shows up at the party, and lets Polydectes know he's ready to give him the promised gift, the head of Medusa, takes it out. He doesn't look at it, but Polydectes does, as do all the rest of the nobility that are standing there, hoping Perseus falls on his feet again. And turns out all the nobility as well as the king suddenly become stone. Okay, so now we need a new king. So Dictys, remember the king's brother who was actually just a fisherman, is now made the king, and Andromeda and Danae set back to go back to Argos. Okay, back home, Proteus, who had been defeated by Acrisius, his brother, redefeated Acrisius, took over the kingdom. Perseus raised up an army against Proteus, killing Proteus, and then Perseus became the king of Argos. Danae did want to mend fences with her father, despite locking her up in an impregnable tower and then setting her adrift in a chest because he wasn't going to kill her. I'm not sure what he thought the results of putting her and her son in a chest and shoving it off into the ocean was supposed to be, but, you know, we digress. But she wanted to mend fences. Perseus promised to find him and to allow him to live his remaining days in Argos. Acrisius was attending, gee whiz, a party. And as part of the festivities, there were lots of contests of strength and skill for everybody to join into. And of course, Perseus was not going to miss out on these types of events. And during a discus throwing contest, Perseus took the disc and threw it with all his might right on the target. But of course, you know that that Perseus has to in some way kill his grandfather. So while he's throwing this stone discus, a wind, okay, would have to be something beyond a hurricane, comes up because that can then take that stone disc, blow it off target, and hit Acrisius. So indeed, Perseus did in some way cause the death of his grandfather. Got to be a heck of a windstorm that can take, what can I say? Okay, so that's a little bit of the mythology that we relate to astronomy. So now let's talk a little bit about some of the objects we're going to take a look at this month, and this quarter, some really pretty ones. Stephan's quintet is a cluster of, its quintet means 5. It's actually 4 bound galaxies and another one that looks to be in the same vicinity, but it's actually quite a distance away. Quite beautiful to see. So this is, so this is sort of the region of the sky over here. And this is a Hubble close-up of the galaxies. One of the cool things about looking at some of these objects, again, over the years, is there's now a new guy in town. And this is a web picture of the galaxies. Lot more to be seen there. there are black holes interacting within these galaxies. So there's going to be a lot more research done coming from the observations of the Webb. Just really, really pretty. And of course, that's the U of A camera that took that picture. Okay, and another sort of sky, again, from the sky. So it's in the vicinity of Pegasus Andromeda region. So a little bit of information about Stephan's quintet for you or anyone who's looking at it through your telescope. It's one of the first compact galaxy groups that were found. Again, 4 of them are gravitationally bound, 200 to 350 million light years. They are interacting in a very violent fashion, sort of shredding each other apart. They will eventually merge into one large galactic blob, more in the elliptical shape than the pretty shapes they currently are. But for now, we can get to see it in its full glory. Lots of X-rays coming from this because of all this energy being generated by the gravitational forces and tearing apart stars and making stars as well. Lots of hydrogen up there. The other galaxy is NGC 7320. It's visible. It's, you know, if you look at it, you can see it there, but it's actually only about 39 million light years away. So it's not part of that group. It's just in the same part of the sky, but it's still called the quintet. So another object we'll take a look at is Able 262. And again, this says Webb Deep Sky, but that's a website. It's not the Webb camera. And we can see, neat thing about looking at some specific objects is to see how much there is around it in the sky. You know, there are very few parts of the sky we can look at that just are totally empty. Okay, and it's located down here. Here's the star Almach, which we'll talk about later. And here are the RA and DEC. Should have blown that picture out a little bit. But okay, so it's part of a chain, a cluster chain of galaxies that run between Perseus and Pisces. It's one of the largest such clusters. There are about 200 galaxies in the region, and a large number of them are actually spirals, which is rather unusual. Normally, when you have galaxies this close together, you've had more of the interactions, and they tend to have more elliptical galaxies because ellipticals are probably the result of the combination of galaxies, spirals, just as they, you know, lose their structure during these interactions. The image, the Chandra image was about 440 million light years across. But again, within that region, there are a couple of hundred galaxies, about 200 million light years away. There is at least one supermassive black hole there, which is NGC 708. And there's a massive gas cloud totally surrounding this area. Again, the galaxies are interacting to some level. So as stars get shredded, the gas will be released and will join together. And if you get a sufficient amount of this gas that joins together, you still have other gravitational forces, which mean you're going to potentially end up with more star formation. So you might be destroying stars, but you're going to create some as well. Unfortunately, the more times you go through this process, the less material there is. So over time, this is not necessarily a good thing, but for our purposes, it's really pretty to look at. So Almach, or Gamma Andromedae, right here. Down here, it's one of the stars within Andromeda. But again, stars are pretty. but stars that are a bit more complex are even prettier or a little bit more interesting. And a lot of stars, it turns out, most stars, our sun is actually somewhat uncommon in that our sun is a lone star. Lots of research indicates that the sun did potentially have a companion star a long time ago, but it got shoved off and went off on its way. Just again, gravity didn't allow them to work together. Jupiter couldn't become a star because there simply wasn't enough mass left in our local area once the sun had collected enough of the mass to ignite. Okay, but Almach is a star system. There's a total of 4 stars, but they're all bound to each other in a couple of different ways. Total magnitude is a little more than 2, and it's about 360 light years away. I mean, we can see the single star, what looks like a single star, so it's obviously not that far away. The main star, the A star, is an orange giant, so it's on its way out, but it's got a ways to go. Magnitude of about 2.3. Its size is about 80 times our sun. And again, giant stars, as they sort of like Betelgeuse, as they go through the early parts of the death throes, the gas expands, so it's much larger than our sun. The blue star is a blue-green star. That's actually a spectroscopic binary, which means that you're not going to see it as a binary in a telescope. But if your telescope has things like a spectrograph on it, you'll be able to identify the separate stars. Those 2 stars have a period of about 2.7 days. So they're moving around each other relatively quickly with a magnitude of about 5. But that part is also a triple star system. The C star has a magnitude of about 6.3, and it rotates around that pair every 61 years. So these things are whipping around, and this one's just, much slower around the outside of it. And the total separation within that 3-star system is about 10 arc seconds. Okay, so another interesting object. Not going to talk about the Pleiades specifically, but I'm going to take one star in the Pleiades, Merope, and look at the Merope Nebula. As you look, most of us have looked at many of the the open clusters, especially the near clusters like Pleiades, Hyades, and you can see nebulosity in your telescope as you're looking at these stars, just like we can when we're looking out towards Merope. But it turns out, and in the region of those stars, their star-forming regions, there are gas clouds. However, this nebula is not part of that star system. It just is between us and the star system. It's actually significantly closer. Okay, and so this is sort of looking right near the star, and this is looking at the whole cluster. And of course, we can see M45 and the named stars, and all around there is nebulosity, some related to the cluster, but not this particular bit. It is a reflection nebula in the vicinity, or in the position of the sky occupied by the Pleiades. It's about 30 arc minutes across, so again, rule of thumb, it's about the same size in your telescope as the moon would be. Subtends half a minute of arc. It's about 410 light years away. And again, the interesting part about this is it's not part of the Pleiades. As much as we try to convince ourselves it is, when we look at that, it's actually quite separated. So this is NGC 1535. And here's an atom block image from just up the street, up the hill. And here's a NASA image of the same thing zooming in. It is, of course, a planetary nebula. It's not the Eskimo, but very, very similar in color and basic history. It's just with the NASA picture, you can actually see a little more clearly the intensity of the core star, although it does show up here as well. Okay. And there's where we could find it in the sky, including the RA in the deck. So this one's gonna, like most planetary nebulas, they're hard to see, especially as our eyes get older. Bit of a challenge, but hey, the weather's been nice lately. We've actually had several nights in a row that it hasn't been cloudy. It's been a while. It's also called Cleopatra's Eye. So it looks like the Eskimo, but this one's called Cleopatra's Eye. Okay. About a 4.6 magnitude. It's somewhere between 5,500 and 7,500 light years away. It is, again, not unusual for planetaries, quite blue in color. And it's about 0.65 arc minutes by 0.61 arc minutes. So it's small. It's 0.65, much smaller than the moon. But again, it's an interesting object, and it's worth taking a look at. There are many planetaries out there, and again, they're not really planets. They're simply the gas clouds from stars that have blown up. The star at the center of this will eventually become a white dwarf. But in the meantime, we get to take a look at it. Okay, so Kruger 60 is located in the vicinity of Delta Cephei. So here's Delta Cephei. It's actually located right over here. I didn't move my red dot appropriately. I apologize, but it's, you know, relatively close to Delta Cephei. Here's a picture of it. Sort of, we'll look at it in more detail later. But this is from Sky Map, and here's Delta Cephei, and here is Kruger 60, and here's the sky showing lots of stars. Again, Delta Cephei and the Kruger 60. It's a nice picture of stars. I like stars. Diamonds on black velvet type thing. It is one of the smallest and closest stellar systems that we can see. It's a binary system with two red dwarfs. Magnitudes are about 9.6 and 11.2. They're only about 13 light years away. They're, again, red dwarfs, so they're relatively small in scale. So about a quarter the size of the sun and a 0.16 times the size of the sun. And their luminosities, one is about 1/100th that of the sun, and the other is not really putting out much visible light at all. That would be 0.34% of the light that the sun puts out. This binary system rotates around itself with a periodicity of about 45 years. The average separation between them is similar to the distance between the sun and Saturn in our local solar system. So they're on an astronomical scale, relatively close to each other. The B star is interesting in that it's what's called a flare variable. It sometimes brightens to a point of being much brighter than the A star, and this happens in a matter of minutes. So here is a light curve for Kruger 60, which is also DO Cephei. And so you see that we look at the average light coming out, and all of a sudden, you know, and this is September 14th, 2007. So here's the light, relative light at 10:45. And here's the light. That's what this is about 10:55. And then it just sort of drops back down and then approaches its average within, you know, a few minutes. So you have to be looking. Okay, so the next object we'll talk about is NGC 281, as well as IC 1590, which is an open cluster within the region of the nebulosity. And beautiful pictures. And I got to admit, I can accept the name of this nebula. It's called the Pac-Man Nebula. So I can sort of accept that much more clear on the screen here, but I'm going to say, okay, I can accept that as looking like a Pac-Man. There's even the little eye right up there. Okay, so they are located within the area we would associate with Cassiopeia. Again, the RA and DEC are listed there. So again, it's called the Pac-Man Nebula. It's about 10,000 light years away, and it's about 1,000 light years above the plane of the Milky Way. Diameter is about 80 light years, substantial size. The stars are still, it is still forming stars within the gas clouds. There are also what are called globules, and these are accumulations of gas and dust that have the potential to turn into stars if the gravity, if it gets just enough gravity, just enough mass to fall on in and to ignite fusion. IC 1590 is an open cluster. It's about 300 stars, give or take. And of course, like most open clusters, it's young stars, about 3 million years old. A lot of them are high mass stars, which means they're not going to live very long. Okay. Well, the more massive the star, the shorter its lifetime. Fortunately for us, our sun is not overly massive, so it's going to survive long, or survives long enough for life to develop. And obviously, I can't do one of these talks without at least having a Messier object or two thrown in. So I thought we'd talk about Messier 76, which is again another nebula. This is the Dumbbell Nebula. It's NGC 650 and 651 because prior to being really good telescopes, this did appear to be two separate gas blobs, two patches of nebulosity, but in reality, they are connected. It is simply one object or one region of gas. And yet it's, well, I guess technically this one is the Little Dumbbell. It's very close to double cluster and also reasonably close to Almach. So again, this is called the Little Dumbbell. It is another planetary, but it's bipolar, which simply means it has the two lobes. Like most planetaries, if we can see them, they have to be relatively close because they're not very bright or very big. So it's about 2,500 light years away. And it's about 2.7 by 1.8 arc minutes. So much larger than the previous one. That was 0.6 by 0.61 arc minutes, but it's still relatively small. The gas is expanding by about 42 kilometers per second. Actual diameter is actually about a light year. And again, when you consider this is just the gas that's coming from an exploding star, you know, light years gets to be pretty big. Visual brightness is only about a 10. Again, all planetaries are somewhat hard to see, but this is definitely a good telescope object. The central star, on a good day, the magnitude is down to about 16.6, and it has a temperature of 60,000 degrees Kelvin. And eventually that star will cool down a little bit, at which point it becomes a white dwarf. And it's time to start thinking about looking at some variable stars. And one of my favorites is R Lyrae, which is way over here relative to the constellation Lyra. And it is a variable star. it is sort of a standard candle. It's the properties of this star help define the properties of similar stars in other parts of the sky, which allow scientists to calculate a lot of information about other galaxies simply by looking for this type of variable stars. This particular star has a period in brightness and dark, a full cycle of brightness of a little more than half a day, 13 hours. So you can see most of a cycle in the course of one night. And remember, we're talking about things you'll be able to see in December where our nights are a little bit longer. Magnitude variation is from about a 7 to an 8.1. So it is going to be a noticeable change in brightness. It also will change slightly in color from about sort of a whitish appearance at the maximum brightness, much more yellowish near the minimum. It's about 850 light years away. Wilhelmina Fleming first isolated this and understood what, started to understand what this periodicity was useful for. And she was one of the Harvard computers, those women who did all of the work at Harvard in astronomy, but never got credit for it. So I like to bring those people up when we have an opportunity, because women were never given credit for doing the work that was done. And this is the intensity curve of RR Lyra. And you can see that it's rather cyclical, and it comes up, goes down, comes up, goes down. So you'll notice that its increase in brightness is much faster than its decrease, and then goes back up and goes down. And again, does this every 13.6 hours. Okay. These are basically, again, this is the first known of what are now called the RR Lyrae stars, and they pulsate over very short periods of time. And we can use that information to understand how far away other objects are simply by looking at what their periodicity looks like from Earth. Okay. So these variable stars are, again, periodic. They're often seen in globular clusters. Most of the variable stars in globular clusters are of this type. Initially, they were relatively small stars, so smaller than our sun. They are already losing mass, so they're older stars. The other interesting thing is they have a very small, low metallicity. Okay, what metallicity means in a star is what generation it was. So the very first stars that were formed had a metallicity of 0, because the only things that existed in the initial universe were hydrogen, hydrogen, then helium, etc. The next generation of stars could have some metallic content, because we'd had supernovas of the first stars, and as the gas compressed to form the next generation of stars, there were materials other than hydrogen. So if you look at the metallicity or the non-hydrogen helium content of a star, you can sort of get an idea of how many cycles have gone on before the material that formed that particular star was originally found. So obviously these are, if they have very low metal content, then they have to be very old stars. And again, periods of these are typically well less than a day. And again, by the standard candle, what that means is we can look at RR Lyra, we can see how its brightness varies. And if we see a similar object in a globular cluster, we can also see how its brightness varies. If you have a point source of light, light radiates out uniformly in all directions. So as you move away, the brightness drops as the square of the distance, because for a given angular subtense, the further you go away, it actually drops because the area of the sphere increases. It goes as r squared, not as distance squared, not 1 over distance squared as opposed to distance. So by knowing how the brightness changes, you can get an idea of how far away another object is. Just the cool things I like to do. So that was it. So can I just take this off, Jim?
So thank you, Dr. Turner. We'll do questions in the room. Do I have hands in the room? Any questions? Yes, okay. And as some of you know from before, I'm climbing stairs with microphone in between speakers here. And so it'll take me a minute to get to the question. Did you have a question?
Dr. Turner, in the Pleiades, you indicated that there was a star in that cluster, but the nebula was way in front of that. How do they determine the distance to a nebula as opposed to a star?
It's the same basic process. It is looking at what the intensity is. And you can also look at the relative movement of objects as you go further out. Again, the angle they move over a given period of time will be different.
Thank you.
Okay, we have another question. I'm coming, Paul. Okay.
Okay, you mentioned that the nebula in the Pleiades was actually between us and the Pleiades.
This
cluster.
particular part of the nebula, yes.
Yeah.
Of the nebulosity.
Well, it's a reflection nebula, so therefore it doesn't shine by its own radiation. So it takes something to illuminate it. So it's my understanding that now I did hear that the Pleiades, in fact, is not associated with that cloud of dust, but it happens to be passing through it. That's what I've heard. And then the stars themselves are, you know, hot. They're hot items, by the way, you know, they're blue. And they of course illuminate the dust as they're passing.
But it's not, there is still dust associated with the Pleiades because the stars are still relatively young.
Yeah.
But this gas cloud has nothing to do with any of that.
Mhm.
Right.
But they happen to be passing through the dust. It's independently, on an independent path around the galaxy. And they have to, something has to illuminate the dust for that to, otherwise it would just be, well, a dark nebula. And there are plenty of them in the sky. So they still are illuminated, even if they weren't actually formed out of it or otherwise associated with it.
Yeah, they are absolutely illuminated by the light of the stars.
Yeah.
Yeah.
Okay.
Yeah.
Okay, another question in the room? Okay, we will move to the online questions here.
Okay, on Zoom, and I brought it up in the chat up on the screen. Wade asks or mentions Kruger 60. Wonder if there's a theory explaining the cause of the sudden brightening dimming.
Not that I have seen. Sorry. Yeah, I have not seen a cause that was written in a way that I could understand. If someone's found one, that I'm a different sort of physicist.
And that was it on Zoom.
Okay, do we have questions from Facebook? Okay, no questions at this time from Facebook. Okay, well, Dr. Turner, thank you so very much. We always look forward to Mary's presentations. I neglected before to introduce our meeting team tonight, so I'll do that right now. We've got Jim Knoll, who is helping to work the computer system. We have Susan Knoll, who is operating our camera. And we have Bob Rose, who is in charge of Facebook. And I'm May Smith. I'm the TAAA president. So now we have some other shorter activities tonight, shorter but very important activities tonight, shorter presentations, but lots of activities. And we've got to get our microphone. We can. Okay. Okay, we're going to do an announcement first here before we get to another speaker. We have Pete Hermes, who is our nominations and vocational resource person, volunteer resource person, I'm sorry. And Pete is in charge of the Constitution and bylaws vote. And so he now has the results and we'll pass that to you. Do you want my microphone?
Good evening, as May said, my name is Pete Hermes. I'm the chair of the MVRC. That's the one we want to see. John Christensen and Dave Pass are also members of the committee. We're short one, so we're still looking for someone. But anyhow, that's great. It doesn't see. Oh, I know what I did. I've got the results. I didn't send that one to you. Yeah, let's do that. My apologies. That's okay. No wonder the numbers aren't up there. I wasn't able to psychically send that to Jim. Okay, let's try this. There we go. That's what we want to see. Anyhow, I appreciate everyone that voted. We had 202 members voting on this particular proposal, and it was closed at 7 o'clock. Interesting enough, Mayor announcement was worth something. We picked up about 3 votes during the meeting. So, be that as it may. Anyhow, the results are reported by APA vote 178 approving, 24 not. There was a 2/3 majority required for approval of this proposal from the board. Therefore, it is approved, needing a minimum of 135 votes for approval out of the voting membership. So, and just to review, and one thing too, I'd just like you to pay particular note underneath my name up in the upper right-hand corner. I appreciate any communication from the membership. MVRC chair at TucsonAstronomy.org. And I'll say something about that a little bit more. And anyhow, if you all wanted to know, just to review what the this is the segment of our Constitution bylaws that will be implemented effective immediately for regarding term limits for 4 principal officers on the board: president, vice president, secretary, and treasurer. And that's just for review. You should have all seen this before, but just in case someone forgot what we were voting about. Are there any questions? Any questions on chat? No, okay, very good. In closing, just one quick announcement. In the coming months, and certainly we'll have another election for some of the positions. In fact, secretary, treasurer, 2 board members, 2 members of the MVRC come up for election this upcoming May. So I would ask the membership, in person, online, wherever you may be, to seriously consider putting your time in on some of this valuable work. The organization has grown considerably. I've only been with the club for a little over 2 years, and I know that there's a couple of key members on the board and in some of these positions that have been with the club a short time. And I would ask the membership just to definitely consider putting some time in. Some of these, MVRC is real easy. We meet remotely. You don't even have to be present. In fact, some of our members aren't even in Tucson. But I'll be coming before the membership repeatedly through May, asking very politely as we get closer and closer to May and we don't fill any of those positions. And I've got a couple of guys and girls that I'm going to send out to visit them. No, not really. But I just ask you to really consider putting some time in to continue the legacy that has been built by the leaders and the membership over the past 30, 40 years, May. So, and longer. So this club functions pretty good. I've been rather amazed and it will continue to do so, but we need people, we need new ideas, we need other ideas. So I'll leave that, and if no questions, I'll turn it back over. Thank you.
Thank you. Yes, TAAA started in the 1950s, so we're certainly, an organization that has grown and developed and thrived over the years, and we wanted to continue doing that. So now we're going to have a presentation sharing some information here by Bernie Stinger, who is going to talk about the Star Party program. And this is the general Star Party program where we do free Star Parties for our schools and for nonprofit organizations. And we're very proud of all of the activities that this group does. This is a hallmark activity for our club. And because our basic mission is sharing the sky, and this is certainly a wonderful, incredible way to do it. So are you set with your microphone, Bernie? No, okay, maybe.
Can you hear me? Good, good. Now we got some more technology up here to figure out. Left and right, okay.
Looks like you brought up the wrong one.
No, I don't want to do yours. That won't work. It's not going to work either.
Okay, there you go.
Okay. Good evening. My name is Bernie Stinger, and I am the school public nonprofit Star Party manager for the club. I've been in this position for almost a year, last November. And I started that position. I took over actually from Jim Knoll, who has done this, who had done this position for a number of years. And I'd like to thank Jim, and I think we all should thank Jim for the years that he spent doing the school and public Star Party program. Thank you, Jim. Appreciate it. He made it a lot easier for me by documenting it and having the organization built in so that I could pick it up and move smoothly with it. I took it over in last November, and what I didn't realize was that November is the, well, what's the word for it? Yeah, it's the hardest month of the year. There was 25 Star Parties that month. And I suddenly was in a fire roasting. So trial by fire, but I got through it and learned a lot by doing it. Just to give you a little background on myself, I've been in the club for 7 years now, going on 8. I'm originally from Minnesota, or as we call it, Minnesota. And I've been in the Minnesota Astronomical Society since around 1980. They're an excellent club as well. They have about 700 members, so roughly the same size, maybe a little larger. They do their outreach differently. They have one central location. It's about 45 miles out of town. And if you want to see a star party, you've got to travel there. That's it. They don't do it anyplace else. We do it completely differently here, and it's one of the reasons why I really liked the way that it's set up here in Tucson, and one of the reasons why I liked taking over this position and managing this group is because we go out to the schools. We go to the schools where the kids are, where the adults are, out to the parks, and actually give them more of an opportunity to get involved. So let me move on here. What is the value of outreach? Well, I'm probably speaking to the choir here, but for those of you who aren't involved with outreach, I think the most important points here are that it inspires future generations and also it educates the public. There's nothing more important than getting the future generations, those young children, excited about science and STEM in general. There's nothing more important. And there's nothing better than to see the glow in a child's eyes when they look through a telescope for the first time and see something like Saturn. Our outreach in the club has 4 separate sections. The school and nonprofit, which I manage, the Tucson Stargazing Adventures, which Jim Knoll manages, the Star Messenger Group, which Terry manages, and of course the Grand Canyon Star Party, which it currently is under Jim Knoll as well. So why do we do it? Well, obviously, it keeps our own personal interest going. There's a certain amount of joy from the public and obviously the appreciation from the schools as well. I continually get thank you emails from the schools saying, we really appreciate what you did. The kids loved it, and we will certainly have you back again in the future. By the way, there's a picture of the Grand Canyon there, and you might notice, if you look closely, where'd my pointer go? I had a pointer here. Oh, here it is. I think this one might work. I think that's Dean Kettleson there with his monster scope that he would bring to star parties, and I was always amazed to watch him haul this monster out of his truck and set it up. I couldn't even pick up one piece of it, much less that whole thing. So how does the star party system work? Well, generally what happens is the schools fill out a request form, which we have on our website. And I work with that request form when it comes to me. Take off the information, call them back, tell them yes or no, this date will work. No, you're going to have to shift it to a different date. That date's too busy, and so on. We also involve a number of state, national, and county parks in the area. And in fact, we're increasing that number this year. And I'll talk about that here in a little bit. Right around the middle of the month, I'll put together all of the star parties for the next month and send out a volunteer request. And that goes out to every member of the club, not a specific group. Every member of the club should get that. Usually around mid-month, I try to do it about the 17th and asking for volunteers. And then when I start getting feedback, people volunteer, and when it reaches a maximum number for that particular event, I will draw a line and say, okay, sorry, that one's already full, but there's other ones still available if you're interested. These events are posted, at least the public ones, on our Facebook page and also on on our website. And of course, at the general meetings, I will generally have sign-up sheets here in case anyone is interested and didn't get the email. Let me see. A few days beforehand, I'll send out a reminder email, just reminding you that you volunteered for this, remember? That's usually not a problem. I've rarely had anybody come back to me and say, oh, I forgot, but it has happened. So a reminder email does go out. By the way, we do mentor new volunteers. If anybody wants to give it a try, who hasn't done it before, we can certainly put you under our wing, bring you onto a particular event, and pair you up with someone who has more experience and can kind of show you the steps. It's not that complicated, but we can certainly do that. Many of these events also have toolkits. Toolkits are what Terry showed you yesterday or last month. I think she broke down a toolkit on the table here to show you what one of the toolkits are all about. So a lot of these events will have outdoor scopes plus toolkits on the inside. All of the start parties, all of the volunteers, the number of hours, that's all recorded down on spreadsheets. So that is available, and I have information going back for probably more than 10 years, dating back to when Jim started the databases. So if you want to volunteer, what do you do? Well, obviously, one of the things that you can start with beforehand is look at star charts, check the magazines to see what's in the sky at the present time, look on websites. Different apps will give you information on what's visible at that particular time of year or that particular night. We also have an object list that Jim and I have added onto over the years that are available if someone wants a copy of those. And one of the things that are quite often interesting for the public is when it first starts getting dark and you need to set up your scope. We need alignment stars. But they're also at the same time going, what's that star up there? Or what's that star over there? So knowing your alignment stars and being able to explain to them, that's Arcturus, that's Spica, that comes in very handy. Also, one thing that is very, very popular, especially with adults, is any kind of folklore or myths or legends that you can tell them while they're viewing objects in the scope. Some of our members are much more proficient at that. I'm not a big legend person myself, but Jim O'Connor, for example, loves to talk about folklore and legends. So we generally try to limit it to 4 or 5 objects per night. Don't need to make a big long list of things you're going to look at because you'll never get to them. Last weekend, I was at Oracle State Park. I got to 2 objects over 2 hours of time. That was it. There's no way that you can get past 4 or 5 objects in one night. There's no point looking for faint fuzzies. You probably won't find them in the amount of light that you've got present in the area because these are rarely real dark environments. Sometimes they are, but schools definitely not. So stay away from faint fuzzies. Double stars are nice. Bright galaxies come in handy. What I like to do is look up supernovas, comets, anything that is transient. That seems to be very popular, especially comets. The green comet of last year was I think I was on the Green Comet for 2 hours straight at the Catalina one of the Catalina star parties last year. So anything recent like supernovas and comets. And of course, ISS passes are always interesting. There's a number of websites that you can get information on. I'm not going to go over these in any kind of detail. It would take hours to go over all of these, but the more common ones, Sky and Telescope is a good one, Astronomy, Heavens Above, space.com. Those are the ones that are catching my eyes right offhand. So websites are very handy. There's also a number of apps that can be utilized on your phone, or for that matter, that the public can maybe look at beforehand. Again, common apps that are very popular. One of the ones I like to use is Sky Live. Safari Pro is a good one. DS Browser is another good one. Jupiter's moons, Saturn's moons. If anybody would like copies of this page, this list, or the previous list, this list or the previous list, I have some printed off copies here that I can pass off to you if any of you are interested afterwards. So you're at a star party. What should you bring along, or make sure that you bring along beforehand? The obvious stuff, your telescope, your accessories, your eyepieces, tripods, but some things that don't jump at you right away, but become apparent to you once you get into this more, is a step stool. Kids need to be able to climb up to the eyepiece. Not everybody is the same uniform height. As much as we'd like them to be, they aren't. So what I generally do is I'll set my scope at an average adult level and then use a step stool for the kids to climb up to. It's far easier that way than to do it the other way around, put it at the kids' level, and then make parents do this down on their knees, because they don't want to do that. A small table does come in handy. Star charts if you need them. A green laser pointer is really handy to point things out in the sky if it's permissible at the location. That's typically not a problem, but some places don't like it. A small red light. Now, that's not for looking up in the sky. That's to illuminate the eyepiece. It's amazing how many people don't know where the eyepiece is, or they can't find it in the dark. So if you just illuminate the eyepiece for them and go, look there, that does the trick. A hand cart is very handy if you've got to travel any distance with your gear. I've been on some sites where we've had to haul it 2 blocks uphill, both ways. In the snow. No, well, I don't know. I've never done snow. Maybe you have, but I haven't. And I've had enough snow for a lifetime. I know to Minnesota. But handcart definitely comes in handy. Layered clothing and sunscreen. Well, you're not going to use that at night, but some of these events are solar events. And sunscreen does come in handy, especially if you're going to be sitting out there for a couple of hours. And bug repellent. Not so much here, but in Minnesota, if you don't have mosquito repellent on in Minnesota at night, heaven help you. You will die. They will find your body next to the telescope in the morning because they will suck you dry. Generally, we look for 2 volunteers minimum. There's occasions when we don't, but at least 2. And depending on the size of the of the star party. It could be in quite a few more than that. Tomorrow night, heaven help us, we've got a star party out at Catalina State Park, maybe. Weather forecast doesn't look real good right now. Might have to cancel it. You'll find out. I'll make a decision tomorrow afternoon sometime. But right now, I've got 13 people signed up for that. So a big crowd, but we have crowds that big that need that kind of coordination. Most of these are 2 hours. Informal object deconfliction. Now, deconfliction is a word that I've never heard of before. Jim Knoll came up with that one. Maybe that's ex-military speak. I've never run. It makes sense once I understood what it meant. What that means is if there's several of you out there, don't all be looking at the same object. It gets really boring for the public. A couple of things to keep in mind. Be prepared to operate manually if you have to. Sometimes you can't find your alignment stars and you've got 25 people that are chomping at the bit to look. Well, you might have to do it manually for a little while. Young observers need a little help. Like I say, it helps to have a light that you can put on the eyepiece, a step stool for them to climb up on, and they need to be told, or their parents need to tell them, please don't grab this scope. Please don't yank on the eyepiece, and please don't have s'mores before you come out for the star party. That happened once. They fed them s'mores before, and then they sent them out into the field. I think it was 2 days cleaning eyepieces. Occasionally we'll have people with white lights, but that's rarely an issue. You just need to explain to them that it's not a good thing to have. Normally what I try to do is when they're looking through the eyepiece, explain to them what they're looking at. That it makes common sense to do that, but it's not always intuitive. So what are some common questions that people ask you? Very common one is, how much does your telescope cost? So I generally have a number figured out in advance. Quite often they're quite surprised. They're expecting you to say $25,000. And when you tell them 2,000 or 1,000, they think, oh, that's not so bad. And when they are in shock over 2,000, you tell them, hey, how much did you pay for your camera and your bag of lenses? And then they go, you're right. Wasn't so bad after all. What is a light year? That's a very common one, especially amongst the kids. How many moons does it have? And that's a tough one because Saturn and Jupiter keep changing all the time. And I'm always trying to figure out who's ahead now. I think Saturn's ahead now. I heard Saturn was up to 125, was 135? Oh, 145. See, you're on top of it more than I am. What else? Where is in the sky? How do you find objects in your scope? That's a good one. I tell them the scope does it for me. And they go, really? Wow, that's nice. No, obviously a go-to scope will find it for you, but a lot of scopes don't do that. So an explanation on setting circles if you want to go to that extreme, but generally a planisphere usually does the trick. So a little bit of what's happened in the last couple of years. Since we haven't really reported on the participation numbers and percentages for the last couple of years, I thought I'd break it down into last year and this year to date. So you can see that last year we had about 118 conducted events. About 50% of them are schools, and about 50% of them are public. Last year, they were almost even. This year, they're close to even, not quite the same, but by the end of the year, they might even out. Notice the number of participants that we've had view. Last year, we're well on track to doing that this year. We'll probably exceed it this year, considering that we've still got 3 months to go, and October, November, and December, especially October and November, are very busy months. So 2023 look like it's going to be a very good year, probably better than 2022. And if you think about it, this probably makes sense because we still had some COVID overlap from last year. People were still a little reluctant to go out to events, especially the public events. So with that, here's a breakdown of all the volunteers from last year, 2022, the number of hours, and through the end of August for 2023. So you can see that there's actually quite a huge number of volunteers that are active in the club for star parties. Some of them a lot more active than others. Jim Knoll and Susan Knoll, myself, obviously we're the managers, so we're kind of deeply into it, but there's a lot of other people that are very, very busy as well in the club. One person that I'd like to recognize in particular is Tom Sarko. Tom has a considerable number of hours. He's not by the largest number of hours, but Tom is, in my opinion, unique in that he comes from an enormous distance. He lives in a small town called Las Cabezas, is it? Dos Cabezas. And those of you who don't know where that is, it's this little, maybe 10 families on the road from Wilcox over to Chiricahua National Monument, about 15, 20 miles down that road. So he travels one way much further than 100 miles. So to come to some of the events here in Tucson and drive 200 miles to do it, that's exceptional. And I really appreciate your efforts, Tom. And with that, I'd like to pass it on back to May. Unless there's any questions.
There's questions. Anybody in the audience have a hand? Okay, we've got a couple
here.
of people here. Take me a minute to get to you. Okay, thanks.
You just want to talk a little bit about behavior of astronomers when the kids are around the scope, about how you don't touch your kids unless they're falling off ladders, issues like that?
Yes, that's true. And I didn't really mention that in here, but we do have a minors policy for children. It depends on what level of minors policy we're talking about. We do have different levels. I think this is probably the first and second level of the minors policy. Basically, policy is that we don't touch the kids unless they fall off a ladder, for example, and you have to grab them. We don't touch the kids. We ask the parents to do that. And generally what I will do is when a child's about to get up that ladder, I go, okay, who's the parent here? And if I don't see a hand being risen, I say, you know, Johnny or whomever, where's your mother or father? And if he can't point to them, I tell him, go get him and bring him back here so that they can supervise you.
Yes, I just wanted to mention here too, we do have minor policy training, and all the basic minor policy stuff we fit into one course. It's a 1-hour training, and we do it periodically at the member meetings. It is scheduled for January for this next time. And we invite and hope that that all of our members, as many of our members as possible, will come to this, because we think it's very, very important that everybody understand the principles that we're working on, and you know, how to facilitate this process. You never know when you're going to be a TAAA person representing TAAA in some kind of way at some event somewhere. And then you find yourself dealing with children. You find yourself going into restrooms with children. You find them perhaps in environments where you could be quite alone with a child. And we have rules and procedures for these things. And it's very simple to just get these things in your mind and remind yourself of them. And it really helps a whole lot. So anyway, that's just a plug for minor policy training in January. We do have another question here. Okay.
On the list you showed with, there was one with websites and one with apps, I think you had. There's an app called Photo Pills. I don't know if you've seen it, or I've used it a few times, and particularly for somebody who say, okay, what's going on this week? You go to Photo Pills, it gives you a list of things to look at, the best ways to view it. And I think for those who are not as conversant in the sky, it's a wonderful app to have on your phone or your tablet or your computer.
Thank you. Yeah, this list was compiled a little while ago, and you know, apps are always being added and taken off for that matter. So I'll try to get it on the next release of this page.
Okay. Oh, yes. We have one question here.
Yeah, is it possible to put some of these slides on our website?
Sure, I don't know why not.
Yeah.
Of course, this presentation will also be available on the on Facebook and on YouTube as well. So
Yeah,
you can go back there and take a look at it as well.
yeah, I think that would be great to have some of these right on the website so people can go and find them if they didn't get to attend this meeting.
Okay.
Right. Thank you.
Okay.
That's a great idea, Suzanne. And along with the minor policy theme, we have procedures that we follow in taking pictures of children and the way that we do that. So that'll be part of the minor policy training too. I think I got everyone in this room. Any other? Oh no, I've got another question. Okay. I don't mean, oh no, I just meant, oh no, because I had skipped you.
I just wondered if we still have to be fingerprinted, because that was on the table last year, the year before.
No, there are, as Bernie mentioned, there are different levels to the minor policy training. There are two major levels in the minor policy training. And one of those is for people who are doing regular events like star parties and starry messenger kinds of activities and going to schools to help with teachers and things like that. So that's one level of kind of interaction, or when children come out to one of our dark sky sites. That's one level of interaction you might have with children. Another primary, at much more advanced level, is our level of procedures for dealing in remote environments or with overnight situations with children. So like we have had several school groups come out to our CAC facility, spend the night there. We do training with them, various astronomy programs while they're there. And of course, we have them, normally their teachers come, normally it's not just parents, but parents and teachers come and bring them. We have a lot of procedures that we follow for all of that. But if you are spending the night with children somewhere, or you are working in remote sites with children on TAAA's behalf, remote sites where there's just not many people, then we do ask that you be fingerprinted for that. For other activities with children, star parties and going to schools and things like that, we don't ask fingerprinting. But for the remote activities or spending the night in much more remote environments where children will be, we do ask for fingerprinting for that. TAAA, we have a procedure for that, and TAAA pays for the fingerprinting for that. So, and that will be talked about again more in January.
Bottom line, the public nonprofit school star parties, which I manage, do not require fingerprinting. Okay, we've got a couple more questions here. Thomas O'Keefe asked, are laser pointers permitted? Yes, they are. The one thing that I'd like to point out with laser pointers, make sure you don't point at planes, of course. Don't point it down. Make sure it's always pointed up. Don't point it at people. Quite often the kids will ask, where did you get that? And I don't answer their question. The other question, are these purely visual events, or are there some imaging setups to accompany what people are looking at through the eyepieces? Very definitely we have imaging setups. I myself have an imaging setup that I quite often will use in lieu of just visual through a telescope. So quite often what I'll do is look at the star party request itself. You know, is it at a location where there might be elderly or handicapped or people who have a difficulty getting up to a telescope? And I'll make sure that I bring my visual setup or my imaging setup instead. So imaging setups are acceptable. The one thing about imaging setups is if you want to try doing that, make sure you've got one that you can jump from object to object in a relatively quick period of time. You don't want a setup that it's going to take you 5 minutes to acquire an object, because there's 20 people standing in line here. They're not going to wait 20 minutes or 5 minutes for you to acquire an image on your screen. They want to see it then. So make sure it's quick. Do you ever do EAA at star parties? I think I just answered that question. Yes, we do. But not strictly EAA. It's a combination. So we do visual or a combination of EAA and visual. EAA is electronically assisted. For those of you who don't know what EAA means. That's basically imaging. And I think that's it. Any other questions? All right.
Okay.
Thank you for your time.
Thank you so much, Bernie. Trying to make sure my microphone's working here. Press the button too many times tonight. We want right now, we have some other things left to take care of tonight, but we want right now to say goodbye to our visitors who are attending on Facebook. We really appreciate, their coming and being with us, and hope that they will come back every month and visit our website. And so we appreciate your coming.